So when we are working with polynomial expressions that involve multiple terms, it would be nice if we can find something in common, and as we take it up, you will be able to simplify your expression. You may be able to lower the degree of your expression, so make it easy to work with. So here in example number 1, if I have a rectangular prism having length L, width W, and height H, you can probably come up with an algebraic expressions for its surface area. But the surface area will consist of multiple terms. It will consist of the surface area at the front and back, the top of your box, the bottom of your box. You can also work with the left-hand side of the box and the right-hand side of the box. When you add them all together, it will give us the surface area for this entire figure. But all these surfaces will have something in common. And if you can take out the GCF from the entire expression for your surface area, it simplifies your calculation. So here in example number 1, if I'm to look at the left-hand side and the right-hand side for now, those two sizes will have the same area. If I have H for the height and W for the width, the area on the left and on the right will both be the width times the height. And knowing how we are having the left side and the right side being the same, they will add up to 2 times W and H. So that's the left side and the right side. I can also find out the area at the front and at the back. Or if you prefer, you can find the area at the top and then at the bottom. So let's say if I want to find the area at the top for now, it will give us a rectangle, and I can calculate the area using length times width. Length times width. And since we have both the top and bottom, as you add the two of them together, we have 2 times length times width. Finally, we want to find the area at the front, the rectangle at the front. For some reason it is not showing up. The area at the front and the area at the back. They have the same area. They do have the same area. Length times height. So when you add those two together, we have 2 times this and that. If you want to find the surface area, you will be adding the 6 of them together. But seeing how each of them will eventually come up with the same factor in all 3 terms, I can take out the 2. So that's the benefit of finding the GCF at the beginning. Instead of finding twice of your length and width, twice the width and height, and twice the length and the height, and add them together one at a time, you may want to just add the 3 of them in one step, and as you times that answer by 2, you will have the surface area. You don't need to times everything by 2 one at a time. You can leave it until the very end and multiply everything by 2.